All right, you guys. So we are going to continue today. I hope everything's going well with you. I hope your family's safe and feeling well. We're going to continue with 8.4 overloaded operators in detail, of course. So go ahead and click on this, and it is going to open up Education C++ Institute 8.4.1, and we are continuing with overloading the subscript operator. Now, the subscript operator, you will know by the brackets for arrays. It cannot be overloaded as a global function. It can be implemented as a class member function. And well, it gives you a bit of the information here, kind of talks about it, and truthfully, you can see it yourself. So, one thing I want to talk about over here, let's look at the program. So, all I've done is I took this, copied it over. So, we have our libraries, and I've got my class right here. Now, remember, it cannot be overloaded as a global operator. As such, it can only be a member function. So what we have is class R for array, and it's got private data, and it's only 4 deep. So it's got A, B, C, and D, and it's integers. Now I have my constructor going on over here. So it's a default constructor, A, B, C, D, 0. If I want, I can create another constructor, and I could have int A, int B, int C, int D. And where I say that this A equals A, and tell you what, let's just get lazy. Control C, Control V, Control V, Control V, and I'll make B, C, D, and B, C, and D. So there you are. I just have now a constructor right there for it. A different one so that it takes in parameters. And right over here, I have my overloaded operator. And I should have put overloaded operator with the brackets. So it takes on the right-hand side an index value. On the left-hand side, remember right here is the this pointer. And so I have int index. So switch on the index. So based on the index, I'm going to do case statements. So if the index is 1, I am going to return this A. And if the index is 2, I'm going to return this B. And if the index is 3, I'm going to return this C. And if the index is 4, I'm going to return this D. And if it is out of the indices, so it's not 1, 2, 3, 4, if it's any number out, I'm going to go to default and I'm going to throw a range error, bad index. Remember, because it's returning this B, or it's returning this A, or it's returning this C, A, B, and C, pardon me, are integers. As a result, this operator overloading of my bracket is going to return an integer value. So there you got it. Overloaded the operator. Let's take a look at the main function right here. So I'm defining an array object R of array object R. I hate it when they do that. And now I'm going to say for I is 1, I is less than or equal to 4, I plus plus. So 4 times 1, 2, 3, 4. Or sorry, 0, 1, 2, 3. Actually, sorry, 1, 2, 3, 4. Forgive me. I'm so used to starting at 0. So they threw me off by that. So array sub I is going to equal to I times I. So array sub, in this case, when I start off with 1, I'm going to say array sub 1 is going to equal to 1 times 1. And same thing, array sub 2, I'm using a mouse. I need to buy a pen, is going to be 2 times 2. And 3 is 3 times 3. You get the idea. And then I'm doing, again, the same concept, but this time I'm going to cout it. So it's really just going to give me the squares. So 1, 4, 9, 16. So there you are. Let's run it. Find out. And I like to clean this up. Just me. Nope, can't run it like that. Let's run it. Yay, drivers are available. Isn't that nice? And the reason it ran 16.941 is because we started at 4 and we worked our way down. So there you go, if you're kind of curious about that. All right, so without any further ado, I think we are done with this one. And we are going to look at the next one. So I have a little thing right here. I don't know if you guys can see it, but it's basically telling me, it's a little bar that says to stop sharing. And, oh, I can move the bar. Well, that's new. Okay, well, it makes life easier, doesn't it? So let me just move that over here, because now I can click my arrows. Okay, so we're at 8.4.2, and we are looking at the invocation operator. It's the function invocation operator, which basically takes in like arguments, parameters. So I got the parentheses. It cannot be implemented as a global overloading, as a global function. I can implement it for overloading member functions. And I can return any value. We're going to take a look at it. Let's take a look at this. I'm not going to read this part to you. You guys can follow along. So, but let's take a look-see. So I have this one right here, and it should be, here you are. Okay, so I have my library, I have my class, I have my main function. So I have a class called fun, and class fun has, it just overloads. It doesn't even have a constructor. I mean, I guess I can give it a constructor. I really don't understand why you wouldn't give it a constructor. But anyway, there you go. So right there, give it a constructor. It's very simple. I have the operator overloaded, which is the parentheses, and it's overloaded so that it takes two values, an integer and an integer. And what it returns is if A1 is greater than A2, it's going to return A1. Otherwise, it's going to return A2. I don't know if you guys remember this, but it is the same. This is a ternary if statement, and it is the same as saying this. If A sub 1 is greater than A sub 2, then I'm going to return A1. Else, no. Sometimes I hate that thing that pops up. Else, seriously, just give me an else. Return A sub 2. So that's exactly the same as this line. It's just that this takes a little bit more effort to type up, whereas this is a lot faster. So let's just put it right back. Else return A sub 2. And I'm overloading the operator, again, the parentheses operator, so that I have A1, A2, and A3. So this is what's going to happen. If A1 is greater than A2, it's going to execute and it's going to check. So it's first checking, is A1 greater than A2? If A1's greater than A2, then it's going to check, is A1 greater than A3? And I just have a cat that just jumped up on the table and he's not supposed to. So sorry about that. If A1's greater than A2 and A1's greater than A3, it's going to return A sub 1. Otherwise, if A1's greater than A2, but A1's not greater than A3, meaning A sub 3 is larger, it's going to return A sub 3. Otherwise, if A1 is not greater than A2, it's going to check, is A2 greater than A3? And if A2 is greater than A3, then it's going to return A sub 2. Otherwise, if A1's not greater than A2 and A2 is not greater than A3, then it's going to return A3. And cat's on the table again. So essentially what these two overloaded operators do is they take in parameters A1, A2, or A1, A2, A3, and it returns the largest of them. That's basically what it does. So when I call this, this should return 2, and this one should return 3. Whoa. All right. So it's a fancy way of just putting it all in one. There you go. This is like a nested if statement. If you want, I can rewrite this. So I can say if A1 is greater than A2. If and A1 is greater than A3, return A1. Return A2. Okay, and else if A2 is greater than A3. So if A1 is greater than A2 and this ends up being false, it's going to go to the else, meaning A2 is larger. If A2 is greater than A3, it's going to return A2. Else, I really hate that that comes up. I'm going to return A sub 3. So all of this is a short way of saying all of that. And that's basically it. And truthfully, it's going to turn the same thing. I know it looked like it was on a different line, but it's actually all on the same line because the semicolon's here. So I can do this. This will run, still give me a 2, 3. Boom, bada bing. This looks a lot, I don't know, nicer maybe. You just kind of have to read it a bit more. So whatever works, right? All right. So that is the end of overloading the parentheses. So let's take a look next. I know you're like 18 slides. Are you serious? Yeah, cereal. So you can overload the pointer operators. Okay, so we have the dereferencing, we have the pointer. Can it be implemented as a global? Yes. Can it be implemented as a member function? Yes. So I have right here the pointer. Yep. So 8.4.3, 8.4.3. Okay. So we have our class P for pointer. And it's going to take in, or it's got as public data, an integer value. The variable is called no for number. I mean, there you go. I got my constructor. So 2 types of constructors. I have my default constructor, which I really would rather that the default constructor was up there. I have my default constructor where it doesn't take any value. And I have my constructor where it takes an integer value and sets no to a value there. And I have my overloaded ampersand operator, which it's going to do a switch statement. Okay. And if the integer has, thank you, if the integer in no has a value of 0, then it's going to return alpha. If it has a value of 1, it's going to return Bravo. And if it has the value of 2, it's going to return Charlie. Okay, so I mean, it's nothing fancy. Now, what I really would have preferred when they do this, of course, is you use the this pointer. Now, for this one, you don't necessarily have to, but oh, forgot. That's in function notation. Can't use the this pointer on that. I can use it on this. So there you go. And I have the operator right here, and that's going to take in a string. Okay, so, and what it's going to do is it's going to create a temporary P variable, object of class P. Also, it's lowercase p. And if s.compare alpha, which basically, or not s.compare alpha, sorry, it's going to set the P pointer to a new class P with 0. Okay. S compare Bravo, P pointer to a new P of 1, P pointer to a new P of 2, P pointer to a new P of, in this case, -1. That's my default. And it's going to return my P pointer. So let's just run it. Charlie 2. Where am I looking at? One warning generated, main, Charlie 2. Oh, okay, duh. So sorry, it made a warning, which kind of threw me off, but this is actually its output. So it's going to see out Charlie 2. So it's going to take the pointer, it's going to set it to 2. Okay. It's going to make a string. Okay. String. And I did not want to do that. Why did it do that? String S, and it is going to set it to ampersand. So it's going to return ampersand of P1, and P1 is 2, so it's going to return in the string Charlie. So I'm going to have Charlie, and now I have the P pointer P2 is going to be equal to, and it's going to call the asterisk that we overloaded, and it's taking my string S. String S is Charlie. Okay, so it's going to take and do the comparison on the string S. So it's going to do s.compare with Charlie. So else if that, it's going to return a new, right there, P object, because right there, with the value of 2. So P2 is going to get the value, in this case, of 2. So that's where you have Charlie, my S, is pointing to the value of 2. And now I'm kind of curious. Control may reach of non-void function. May reach end of non-void function. So let's look at that. It's having an issue with this right here. Control may reach of end of non-void function. Okay, so what it's complaining is right here. The reason it's giving me a warning is I have no default. Okay, so I could say default return nothing. And that should be okay. So it was basically just complaining if I had a 0, 1, 2, what if I had a 3? Or what if it was any number aside from 0, 1, 2? And notice that the complaint went away. So when I run it, boom, bada bing, no warning. So you guys good with that? And we're done with that. And now, these are a bunch of other operators that are overloadable. We're not going to deal with them right now. I'm just going to be honest. We are not going to deal with all these things. By the way, here are some non-overloadable operators. And again, we're not going to deal with that. What we are going to do is we're going to work on and make a program that is a fraction class. Now, you guys know fractions. I know everybody here in this class is like Algebra 2 and above, so you should be able to handle fractions. So let's take a look at this, okay? Here's what our class is going to do. It's going to have two integer fields. It's going to have one field for the numerator, one field for the denominator, and notice they are both private. You are going to have a default constructor, and the default constructor is going to set the numerator to 0, the denominator to 1, so the entire fraction basically gets the value of 0. You're going to have a one parameter constructor, and the one parameter constructor is going to set the numerator to whatever the parameter is and the denominator to 1. You're also going to have a two parameter constructor, which is going to take in the numerator on the left side, the denominator on the right side. Okay? You're going to overload an operator to reduce the fraction. And we're going to use the exclamation point as that overloaded operator to reduce the fraction. You are going to have 4 operators for addition, subtraction, multiplication, and division. You are also going to use 2 helper functions. Now, these functions are going to be private, and the reason they're going to be private is these functions are for us. They're for us as the programmer. They're not for the user of the class. So as a result, both of these functions are going to be private. They're going to find the greatest common denominator or divisor and the lowest common multiple of 2 numbers. It's not going to be of the numerator and denominator. We're not going to do that, but it's a good thing for us to know because it's going to make dealing with the fractions a lot easier. And you're going to have a function that's going to make our fractions readable. So it's going to like print out 3/5. Okay, make it look like a fraction. And you're going to have a function that converts a fraction into a double. So like 3/5 will become 0.6. Okay, so let's take a look and build as we go. First, we're going to make a header file. Okay, and our header file, again, a header file is just declarations. So I'm going to have a fraction class. I'm going to have my private data, which is integer, numerator, and denominator. I am going to have 2 private functions, the lowest common multiple and the greatest common factor, greatest common divisor. Lowest common multiple is going to take an integer x and an integer y. Greatest common divisor is going to take an integer x and an integer y. I have my 3 constructors right here. So remember, this constructor takes and makes it 0 over 1. This one makes it whatever n is over 1. And this one makes it n over d, numerator, denominator. And it's going to throw a domain error if the denominator probably is if the denominator is 0. I haven't looked ahead. So if the denominator is 0, it should throw a domain error. And let's see. I have my get string function, which is going to take our fraction and print it out as a string. And I have my get value function, which takes our fraction and prints it out as a decimal. And then I have my overloaded operator. This is my reducing operator, my addition, my multiplication, my division. I thought they said we were going to have subtraction. Reduce. Yeah, I got my subtraction right here. What's the deal? I don't see a subtraction one. Well, guess we can make it. So, tell you what, first thing I'm going to do is take all this and copy it. And I have a blank one called fractions. So I'm going to create a file, add file, and I'm going to call it, and what do they call it? Fraction with a capital F. So I'm going to add fraction.h. And in fraction.h, boom, right there. Okay. So next, I have my right here two member functions that are helper functions. They're my private ones, LCM and GCD. Okay, so let's take a look at LCM. I have LCM right here. Okay, I took and I converted this right here into just a normal function. So I got essentially took all the code and I just got rid of this right here to show you what LCM does. So when I run it, pound include IOStream, namespace standard, I got my function LCM, which is just a copy. All I got rid of was function right there. And I have int main, so cout LCM. So I'm going to find the lowest common multiple of 2 and 3. I'm going to find the lowest common multiple of 3 and 3. I'm going to find the lowest common multiple of 6 and 3, 6 and 9, 11 and 7, and 4 and 12. Okay? Now, the lowest common multiple is the number that these two numbers make, the smallest number that these two numbers make. So for instance, 2 and 3, it makes 6. 2 and 3 can also make 12. So it's going to choose the lowest. So check it out. Running it. Okay. So the lowest number that 2 and 3 are both a factor of is 6. The lowest number that 3 and 3 are both a factor of is 3. The lowest number that 6 and 3 are both factors of is 6. The lowest number that 6 and 9 are both factors of is 18. You get the idea, right? The lowest number that 11 and 7 are factors of is 77. And the smallest number that 4 and 12 are factors of is 12. Okay, so just showing you what the lowest common multiple does. Now, following that, we have the greatest common divisor or greatest common factor. So showing you what this one does. I'm going to get rid of this. Gone. And we're going to take a look at this. So all I did is I put this into a program here, and I got rid again of the member function status, so I can just run it. So I have GCD right here, and when I run it, well, it was already there because I ran it already. So it's going to find the greatest common factor of 2 and 3. So 2 and 3, they have nothing in common except for 1. 3 and 3. The greatest common factor of 3 and 3 is 3. 6 and 3. Greatest common factor that 6 and 3 have in common is also 3. The greatest common factor of 6 and 9 is also 3. Greatest common factor of 11 and 7, they share nothing. So the answer is 1. And the greatest common factor of 4 and 12 is 4. So again, just showing you guys. So I've got fraction.h. So I'm going to create another file, and I'm going to call it fraction.cpp. Okay. And that is going to contain all of my definitions. So I'm going to take and copy that over, and boom. That's going to be my first part. Okay. And I have to remember to pound include .h. That's interesting. Oh, okay. Forgot. Not part of the standard library. So as a result, I got to put it in quotes because the quotes means check in with the rest of the files here. So that's going to give me that. It's going to just give me hello world because that's all my main does. It says hello world. Would be nice if I say using namespace standard. Boom. So anyway, next one we got. All right. So I have my constructors for fraction right here. So I've got my default constructor, which makes it 0 over 1. I have my one argument or one parameter, sorry, constructor, which is n over 1. And then I have my 2 parameter instructor. Now, here's the thing. It throws a domain error. Okay? And my 2 parameter constructors going to set my numerator to n, my denominator to d. Okay? And it's going to say if the denominator is equal to 0, it's going to throw a domain error because I can't be dividing by 0. So I'm going to take this and I am going to put it back in CPP. Okay? So now, I have my D, all that stuff. One thing I want to add, though, and I have a feeling you guys know exactly what I'm going to say, is this. Okay? There's a domain error. All right. You guys remember what's wrong with this? First off, I'm going to need to include these. Standard except, and string. So Control C. I should take care of that problem. Yeah. Okay. Next one. Namespace standard. Tear that one away. Okay. So I'm actually not sure if I really need this. I'm thinking I don't because I've got everything defined in function.h. And if I'm going to say, or sorry, fraction.h. And if I'm using fraction.h, I'm actually thinking just keep it like that. And nobody seems to have a problem. Now, another thing with fraction.cpp might be good instead of using namespace to get rid of that. And then do the standard part. And that'll be perfectly fine too. And in fact, I'm actually going to kind of leave it like that just because I want fraction.cpp just to reference fraction.h and limit my use of namespace standard. So moving on to 10. Okay, so I've got fraction, get string, all this stuff, void. So I'm going to say do Control C. And okay, so get string. That's going to return a string value. It's going to take my fraction returned as a string. Now, I'm going to be putting it into, and I know you guys haven't necessarily seen this, I'm going to be putting it into the output string stream. Okay, it's kind of like IOStream, where we're couting and such like that, and we really haven't talked about it, but it's using this class called OString stream. Okay, and it behaves like an output stream, but it sends the output not to a file or a device, but to an internal buffer that may be accessed by the str method. Okay, so I'm declaring a temporary variable, OString stream called OS. I'm setting OS equal to bracket numerator / denominator bracket. And then I'm returning os.str here. So this right here will return a string of this. And it returns the string. Okay, now this one right here, fraction get value, will return double numerator, double denominator. Okay, so basically what it does is it turns the numerator into a double, it turns the denominator into a double, and it divides them. And so it's going to return that division. Of course, that division is going to be a double in itself, and that's what is going back. So I think I already copied it, but I'm not going to chance it. So the next thing I'm going to do, and I'm actually kind of following the order that I see it. So I have LCM and GCD. I have my constructors. So the next thing that we're doing is right there. So I can say that 8, 9, and 10. So right here is 8.4.8 stuff. Right here is 8. Oops, comment that out. 8.4.9. And right here is 8.4.10. Okay. And let's do this. So copy, go into here, and what I have is eight dot 4.8, 8.4.9, and now where this is 8.4.10, and should put that out. Now this one is probably residing in standard. Okay, so it's got a problem here. So tell you what, this is complaining because it's unknown type string. Did you mean standard string? Yes. This one's complaining. Did you mean standard? Yes. Implicit instantiation of undefined template, standard, basic. Okay. Implicit instantiation of undefined template, standard, C. All right. So let me see what we got. And unfortunately, things are covered. That's going to probably produce an error. My Visual Studio isn't exactly working properly. So let me just ignore it for right now, see what comes up. Okay, so and here's my main function. Let me go back. So I got my get string going on. Tell you what, I'm going to pause this right now. I'm going to continue it for a moment because I want to make sure I find this error, okay? And I just don't want to be wasting your time. So give me a sec. All right, you guys. So sorry about that little bit of a break that I took. You probably aren't even going to see it as a break, though. What I did is I checked, and this part right here, that they have, and I can pretty much get rid of this. The STD part for standard. Yes, it actually, I just decided, you know what, let's just use namespace standard. So that's going to be the first thing that I'm doing. Second thing, this O string and such like that right here. I needed to add these two header functions. I didn't think I'd really need these header functions because I'm including fraction.h, and when I'm compiling it, fraction.h does these. But here's kind of the funny things is in fraction.h, they didn't include all the headers that we need. And I think the reason that they didn't include all the headers that we need is it wasn't using OString. Or sorry, OString stream. Okay. It was using SStream. Okay. And actually, if you look at it right here, it's not even using IOStream. So I included IOStream in here. So for those right here are being accessed because first off, this right here is not being sent back to the class. Okay, this is kind of like an intermediary class that we're using. So we're using the OString stream, and then we're converting what's in OString stream into a string and returning it. Okay, so as such, I needed these headers in fraction.cpp. So there you are. Sorry for the confusion. Now, next. Kind of went ahead. Got to go back to here. Okay. So next one I've got. We're going to use the not operator. It's not going to be a not. We're just going to overload the not operator, which is the exclamation point, and it's actually going to reduce our fraction. Okay, so it's a very simple operator right there. And what it's going to do is it's going to find the GCD of both the numerator and the denominator, so the greatest common factor of both of them. And once it finds the greatest common factor, it is going to return a fraction constructor, which is going to be numerator divided by GCD, denominator divided by GCD. So that's all it's going to do. So I'm going to Control C it. And now (8.4.11) is right here. Model. Okay, so I have my reduction. And again, I prefer this. So it's going to take this numerator, this denominator, and it's going to return this numerator, this denominator. So that's all it's going to do. Okay. Now, 8.4.12. And I'm forgetting to comment it out. So I got 8.4.12. And now I have the addition operator. So what it does is it's going to find the lowest common multiple, basically a common denominator among them. And it's going to do this type of a calculation. So let me copy it and then let me show it to you. Okay. Right there. And it's kind of long. So let's talk about it. Okay. So I'm saying my common denominator is equal to, well, first off, get the common denominator. So I'm doing the lowest common multiple of the So I've got this side of the operator, so the left side, and I have the fraction side, the right side. I would have just called this right. I don't know why they called it, or sorry, I would have called this right here. I don't know why they called it arg. Okay, I would just say right. And now, right, dot denominator, right, numerator, right, denominator. So, and so I got this denominator, so this numerator this denominator, right numerator, right denominator. Okay, so let me kind of explain exactly what's going on here. Okay, so if I have a fraction, I'm going to say that my fraction is, 1/3 plus 2/5. Okay, so I got 1/3 plus 2/5. I'm going to find the lowest common multiple, so the common denominator. So the LCM and that's going to be 15. Okay, so now I am making my new numerator, and I'm taking basically and saying is going to be, so this is on the left side, and right is on the right side. Okay, so I'm saying this numerator, so 1 times the common denominator, which is 15, divided by this numerator, or this denominator, so divided by 3. So essentially what I'm doing is I'm going to make everything out of 15. Okay, so notice that my new denominator is my common denominator. So I'm going to make it out of 15. Okay. And because I'm making it out of 15, I multiplied 3 times 5 to get 15. So I need to multiply my numerator here by 5. Okay, so to do that, I'm essentially doing 15 divided by 3, which is 5, and then multiplying it with my numerator, which is 1. So this, in this case, this right here becomes 5. And now I'm going to add this addition right here. Okay, I'm going to add the right numerator, which in this case is 2, times the common denominator, which is 15, and the right denominator, which is 5, divided by the right denominator. So 15 divided by 5, that's 3. Okay, and I'm multiplying 2 times 3. And the reason I'm multiplying 2 times 3 is because my number for the denominator on the right side is 5, but it became 15. 5 times what is 15? The answer is 3. So I multiplied the bottom by 3, so I need to multiply the top by 3. So 2 times 3 is 6. So what I'm doing is right here, this whole bit becomes the number 5 plus 5 plus this whole bit here, which is the number 6. So 5 plus 6, that means this whole numerator here becomes the number 11. So I have now a new fraction where the numerator is 11 and the denominator is 15. So I got 11 15ths, 11 15ths. Now, this does not reduce, obviously. You're seeing right now that it's not reducing. So just as an FYI, oh yeah, temporarily forgot how to erase stuff. Now, we're probably going to have residual red stuff showing up because for whatever reason on this screencast app, it doesn't exactly erase everything, or it doesn't show that it's erasing everything. You'll see what I'm talking about. So anyway, going back to mouse pointer. And so when I, yeah, see things show up. Yeah. So I got to erase that. And let's see. Okay. So I got my addition. Similarly, I can do my subtraction, which is going to be the exact same thing, except it's going to be a minus right there. And there's your subtraction. So yeah. Let's move. Okay, so I got my multiplication. So let's copy that. I got that, Control C. 8.4.13. There. Okay, so my multiplication, and essentially what it does is it multiplies the top with the top. So this numerator, and I have this denominator, and I want to see my files for a second. All right, so I got a bit of a problem right here, and it's going to cause a problem when I compile, because I called it arg, and I changed for my addition. I called it right, and I'm actually going to be consistent and call that right, and I'm going to call that right, and I'm going to call that right. Okay. Actually, I can leave that one as arg. Nah, I'm just going to call it right. Okay, so I have that. I'm just doing that. So because, well, I think it makes it a little bit easier to read if I know this is the right-hand side and that this pointer is the left-hand side. So I'm just going to say right and right. So essentially, I'm going to multiply the numerator times the numerator, get the new numerator. I'm going to multiply the denominator times the denominator to get the new denominator. Because that's multiplication. You just multiply straight across, top times top, bottom times bottom. And now I'm going to return the reduction. Okay, so there you go with that. And I'm going to do 8.4.14 because that's going to be the next slide. Boom. Copy it. And paste it in. So, and I'm going to call it again, right? So wherever I see arg, I'm going to turn it into right. Wherever I see arg here, I'm going to say right. And arg here, I'm going to say right. Okay. Now, this one's going to throw a domain error because we can't have division by 0. Okay. So if the numerator on the right-hand side is equal to 0, it's going to throw a division by 0 error. Otherwise, the new numerator is going to be the numerator times the right denominator, because you guys need to remember that when I'm dividing a fraction by a fraction, the fraction on the right-hand side is we're going to take the reciprocal. So the bottom's going to become the top, and the top's going to be the bottom. The denominator is going to be the numerator is going to be the denominator. As a result, my new numerator is going to be the numerator of the left times the denominator of the right. So I'm going to say this for the numerator on the left, and I'm going to say this or the denominator on the left. And my new denominator is going to be the denominator on the left times the numerator on the right. And then I'm going to put them into a temporary variable fraction f, and I am going to reduce it. So now I have next one, 8.4.15. And for 8.4.15, let's take a look. Control C. Okay. So it's the addition assignment operator. So it's going to add, and then it's going to assign it. Okay. So I have my denominator. Basically, this is exactly the same. So wait a second. On the addition assignment operator, did I leave it? Nope, I changed it. Changed it to right. So I'm going to change all args to right. Right and right. Okay. And I'm going to and understand that, boom, we got this. So okay, just making sure I didn't have any errors. So I'm just staring at it for a moment. So it's the assignment equals operator, which, assignment plus operator, which right here I got fraction, and it's going to return the fraction. So basically it's the same thing. I mean, there's really not much in the way of a difference on this. This numerator, common denominator, this denominator, right numerator, common denominator, right denominator. Okay, so numerator is numerator. So the only difference is this time we're changing the numerator on the left and on the right. So this numerator is going to be equal to numerator A. This denominator is going to equal to whatever our common denominator is. It's not going to reduce, and we're going to return this. So there you go. As opposed to just the addition, it's just going to return a fraction. It's going to return a fraction temporary variable called f, numerator A, numerator B. So this one's not changing the left side. It's not changing the this, whereas this one is changing the this and also returning it. So that's basically the difference. There you go. And lastly, last part of code, rather simple. It's the implementation overloaded stream operator. Okay, so we're going to overload the output string operator, and .4.16, boom, there you go. And essentially, it's going to overload the operators so that when we use it and we have output string and a fraction, it's going to basically call the f.getString function. Okay. F.getString. Where is that? F is here, getString, so fraction. So there you are. It's going to call that right there. So whenever we want to output it, we're overloading the little chevron thing so that it will put our fraction in fractional form. So this right here is related to that. So there we are. Now let's take a look at our main function. So main function, it's not highlighting there, so let's take it from the bottom. Right there, Control C. So we got our main function. I'm going to go to REPL.it and go back to files, main function, and I'm going to take and replace this whole thing. So and the reason it's having a fit is I named my fraction file with a capital F. They renamed it, or they named it with a lowercase. So once I fix that, boom, everything's all good. So I've got my main function, and it's going to declare 3 fraction variables. F1 has a numerator of 1, denominator of 2. F2 has a numerator of 2, denominator of 3. And F just is default. So it is 0 over 1. And I'm couting F1 and F2, and I'm calling the function get value for F1 and F2. And remember, the function get value is, where's get value? It's going to be returning a double. Okay, right here. So it's going to take, it's going to take F1. So it's going to return 0.5, and it's going to return, in this case, 0.666666, and it's going to keep repeating it. So let's just take a look at the code. And just look at that. So I'm going to run it. It's going to take a while to compile. And it should compile nicely. Okay, so 0.5, 0.666, and it's going to repeat and round. Okay, and notice I overloaded the chevron, so F1 works and F2 works. Prints it out like that. Now, I'm going to add F1 and F2, and I'm going to store it in F. So I'm going to say F1 plus F2 is equal to F. So when I run it, 1/2 plus 2/3 is 7/6. Okay, I did not do anything to handle, what do you call it? Mixed numbers. Okay, so next one. I've got this right here. So F2 plus F2 plus F2. Okay, that's going to get stored in F. So F2 plus F2 plus F2, 6/3. What if I want to reduce 6/3? So check it out. I'm going to reduce it. So it's 2 over 1. Okay. I'm going to multiply. So when I multiply F1 and F2 stored into F, I have 1/2 times 2/3 is going to be, in this case, it's going to be, well, 2/6, but then that reduces to 1/3. Okay, so works fine. Now, I have my division. One half, in this case, divided by, and they kind of put that in there instead. And I think they did that because they're going to have to use an escape character for the slash. So let's see. I think I'm okay if I do a double slash. I think that works. So let me run it again. Boom. Okay, there you are. Didn't need the double slash. Quotes handled it fine. Okay. And now they declared another fraction, F3, and they made F3 7/8. So frankly, I would have just put F3 here. Because I hate having variables declared all over the place. So F3 plus equals F1. And I'm going to get rid of this because this is the end of my comment, so it was complaining about that. And I'm going to click run. And F3 plus equals F1. So 7/8 plus equals 1/2. And I got 11/8. Okay. So there you are. And guess what, you guys? You are going to overload this now. And you're going to take this entire thing, and this is what I'm going to have you do. You guys are going to first program the subtraction operator. Okay? So I'm expecting you right here. You're going to overload subtraction operator. Okay? And I want you to overload the subtraction operator, but when it returns it, I want it to return the reduced fraction. Also, you guys are going to fix the addition operator because remember, the addition operator doesn't reduce the fraction. I want you guys to reduce the fraction. Okay? So you're going to do that. I want you guys to also you're going to add something right here. Sorry, right here. You have the numerator, you have the denominator. Sorry about that. Numerator, denominator. You're going to add whole numbers. And I want you guys to now handle whole numbers. Okay, so you're going to modify this program so that it handles whole numbers. In addition, not only is it going to handle whole numbers, but for now on, I want everything to show the whole numbers. Okay, and the way I expect you to handle the whole numbers is when you output it, I want to see that you output it like this. Let's say my whole number is 3 1/2. I've got 3 1/2. Okay, where 3 is the whole number. I have the whole number. I have the numerator. I have the denominator. So that's how I want things to be outputted now. But you guys are going to handle whole numbers, which means you guys, you're going to have to figure out how your constructors are going to be. Okay. And you can keep the default constructor here. I don't have a problem with that. So the default constructor, you don't have to change. You do not have to change this constructor. I don't have a problem with that. But I'm going to expect another constructor. With 3 parameters. Okay, so you're going to make another constructor right here with 3 parameters. Okay, now also you are now going to have to change all of the addition, multiplication, subtraction, don't forget that, and division, so that it handles the whole number, because things change now that you have whole numbers. So especially with your multiplication and with your division, things totally change. And so does your addition. You need to handle that. You also need to handle the plus equal. Now, the whole number can be 0. It's allowed to be 0. But you guys are now going to modify this so that it handles whole number or mixed number fractions. And that's going to be my expectation. I'm going to set this so that it's due on somewhere around Saturday. I'm going to be updating grades this weekend. So you guys need to do grades. And by the way, congratulations. Today is done. Or, well, I mean, today is done, but the chapter is done as well. So we are actually getting to the point where we are going to have a test. I'm going to, let me see. This has been kind of a long lesson. So I'm going to give you guys today for the lesson. I'm going to give you tomorrow to work on your work. And on Monday, you guys are getting a practice test. And then on Tuesday, you are taking your test. So just as an FYI, you guys. And then we are going to go on to new material. I have opened up a new course for the extension of the C++, because we're continuing on. We still have not a lot, but we still have more material to go through, and we're going to start going through standard template libraries. And from there, we're going to start working on linked lists and binary trees. So you guys have your assignment. You know what you need to be doing. Again, I'm giving you the rest of today and tomorrow for this programming assignment. Now you know what you need to be doing. All right. Everything's going to be posted on Google Classroom. So good luck, you guys. Again, stay safe and keep up with your work. You do not want to fall behind on this. All right. I'll talk to you guys later. And we're done.